So here we have a formula. It's called Newton's law of cooling, and it talks about, okay, if you have something hot, you have like a mug of coffee and you're going to sit it in a room and wait for a while, how long does it take for it to cool to a certain temperature? Okay, so over time the coffee is going to cool off, and then this formula can tell you, okay, how after how much time, what the temperature of the coffee would be. Okay, so that's the idea of Newton's law of cooling. So a formula is only good as we know what the different pieces mean. Now, it's very common in science formulas for lowercase t to be time. And I want to say this is in hours, but maybe minutes. They'll tell us. I don't remember if it's in, I think it's in minutes. Okay. And then uppercase T is going to represent temperature. Okay, the A here, I'll come back to that. The T sub S, that's the temperature of the room. Or if it's not in a room, say you put something in a car, it would be the temperature of the air in the car. Okay, so that has to do with what they say, the surrounding temperature. Okay, so whatever the temperature of the air is. A is the difference between the hot temperature, the temperature initially, I'll say T naught, minus Ts. So it's the difference between the original temperature of the item minus the surrounding temperature. K is going to be your constant, and we know all about E. Okay, so yeah, it was in minutes for the time, so I'll just put that. All right, so let's scroll up and have this problem. Oh, I'm going to need that formula though. Okay. A cheesecake is taken out of the oven with an ideal internal temperature of 165 degrees Fahrenheit. So that would be the initial temperature of the cheesecake. Okay, finally some math that we can use here. Okay, and is placed into a 35-degree refrigerator. These are in Fahrenheit. Okay, so you're taking the cheesecake out of the oven, putting it in the fridge. After 10 minutes, the cheesecake has cooled to 150 degrees Fahrenheit. If we must wait until the cheesecake is cooled to 70 degrees Fahrenheit before we eat it, how long will we have to wait? Okay, so like I said, now we're talking important. Okay, we go with what we know. We don't know K. We know the T naught. We know the TS. We know the temperature of the refrigerator. And then we have this information right there, that at some point after 10 minutes, the T of 10, so the temperature after 10 minutes is 150. And then we can use this formula that we have to do that. So we need the difference. We need to know what 165 minus 35 is, and that's going to be A. So you take the difference between the hot temperature, the initial temperature of the object, and subtract the surrounding temperature. And what's that? A is going to be 130. Okay, so A is 130. E is going to be E. K we don't know, but the T is 10, so it's going to be 10K up here. The time was 10 minutes, plus the surrounding temperature, which was 35. Okay, that formula then, that equation, we can solve. So subtract 35. This is going to allow us to find K. So divide by 130. So natural log it. That's what my students say sometimes. They're like, natural log it. And then we'll have to divide by 10 to find K. Okay, so let's get a calculator and figure out what that is. So I need natural log, let's see, natural log of 115 divided by 130. Then hit the parentheses, because all that's in parentheses. And then we're going to divide that by 10. And I'm getting k to be negative 0.01226. I don't know how many decimals they're going to use. I'm looking to see. They rounded it off to negative 0.0123. So they went that many decimal places. It should be negative, right? Because it's cooling off. The temperature should be getting, less for our cheesecake. All right, now we can plug that into the formula. So we can say the temperature after so much time is going to be 130. That's not going to change. The A isn't going to change. The temperature we took it out of the oven at and the temperature of the fridge, those aren't changing. E, and now we have K, negative 0.0123. And that is an approximation, T, plus 35. Okay, and now what's the question? Now we have a formula. It says we must wait until the cheesecake has cooled to 70 degrees. So I need my output to be 70. And I want to know how long that's going to take. So I know how much time I have before it's time to eat the cheesecake. Okay, subtract the 35. Divide by 130. And natural log it. You probably know what's coming. And so I'm going to have the natural log of 35 over 130 divided by negative 0.0123. And that's going to equal the time. So I'm going to put this in my calculator, and this is I'm going to go to the nearest minute. Natural log 35 divided by 130, hit that parenthesis, divided by negative 0.0123, and I'm getting to the nearest minute. Time is approximately 107 minutes. Or if you want it in hours and minutes, that's going to be 1 hour, 47 minutes. So you got to wait for like 2 hours to eat the cheesecake.